Hi, so we made it through musculoskeletal trauma. It was my very first video for any of these courses, and I made it for the class of 2017. I hope you enjoyed it as much as they did. Anyway, we're moving on to do our little dosage calc break. And I pulled a case out of your Evolve HESI case studies. It's in the pediatric section under compound fracture, and it's a great review. Even though it's a kid, it's not specific to pediatrics as much as it's about traction and cast care and all the issues that happen with musculoskeletal trauma. Anyway, right now she needs morphine, Cora, and it's ordered in a weight-based dose like most peds drugs are. And we need to talk a little bit about morphine because morphine, we know, is an opioid narcotic. If you were one of those good people that did your ATI templates, you know that one of the adverse effects can be respiratory depression. And especially with kids, you want to be very careful because they can go into a very serious emergency state with respiratory issues. And because this dose is weight-based and because we don't have it prepackaged and because it's IV push, this is not going to be a very forgiving situation. If we give the wrong dose, if we give 10 times too much, we're really going to kill a kid here. So we need to pay attention. We need to do it right. Remember, Cora's mom is watching. So let's move on. Cora weighs 33 pounds, means we have to convert. And the medication comes up in this kind of packaging where it's 5 milligrams per ml. So it's not a 1-to-1 ratio. We have to be even more careful. So let's kind of shrink some of these down and make that a little bit smaller. I apologize, I do not have my fancy stylus today. I only have my finger. But we're going to go ahead and set up our dimensional analysis. And I know that your book moves like left to right. I move right to left. I like working backwards. I like beginning with the end in mind. I think it's always a good policy. Begin where you want to finish. Know what you want to achieve in life. It gets you further. Anyway, so we know that we want to give a drug in milliliters. That's how our syringe is marked. That's how we're going to know how much. What we don't know is how many milliliters. So let's go ahead and work backwards. We want milliliters on the top, so 1 milliliter in those vials is equivalent to 5 milligrams. Now we have to get rid of milligrams because it's not in our answer. So let's go ahead and put our 0.1 milligram per kilogram here. And kilograms isn't our answer either, so, and we have to do conversion, so we might as well do 1 kilogram equals 2.2 pounds. Now we have to get rid of pounds, and Cora weighs 33 pounds. Now if you want to keep this nice and neat so that you don't confuse yourself, each one of these little things can get a line. And you can make your top here and your bottom there. That's up to you. That's optional. It's just a way to organize the way it looks. Anyhow, I'm going to shrink it just a tiny bit so that we have some more room to work. So the next thing we're going to do is make sure we set this up right. Does everything else cancel? Pounds cancels. Kilograms cancels. Milligrams cancels. And what we're left with, the last man standing here, is mLs, which is exactly what our answer said we wanted or needed. So now we can go ahead and multiply across so we know that we set it up correctly. I'm going to switch colors. If I multiply the top line across, I end up 33 times 0.1 is 3.3. Get your calculators out. If you can't do that in your head, it's fine. I don't judge. And then we can multiply the bottom. 2.2 times 5 is 11. Again, using your calculators if you feel the need. When you do the division, and I can understand the need for calculators there, you are going to end up with a dose of 0.3 mLs. Okay? Now, a word about that 0.3 and the 0.1 up here. I'm going to highlight them because I think they're important. Okay? A lot of you, or maybe just a few of you, are forgetting to put that leading 0 in front. Well, let me tell you something. If you have to take a verbal and you write something like 0.3 mLs, somebody else is going to look at that and think you left a stray mark with your pen right there, and they're going to give 3 mLs, and that's 10 times the amount of medication that you needed to give that child, and it will probably make her stop breathing and put a lot of excitement on the floor when you get the code card out. So we don't want to leave that like that. We need to have the leading 0. When you see a 0, you know there's a point. 0.3, you know that it's a fractional dose. So never ever forget your leading zeros unless you want to kill a kid. And if you're interested in that, you probably should find a different nursing school because we don't let you do that here. Anyhow, about trailing zeros. You would never have 0.300 or 0.30. You'd never put a zero after. And that's because you don't want somebody to see that and think, wow, that could be 30 mLs. You know, you don't want people to get the wrong idea. So definitely be careful with your notations. And now I'm just going to say a quick little thing about rounding, because that is also noted to be a little bit tricky for people. So now there are some things that are going to be rounded to the nearest whole number, like IV drops. When you're counting drops, you can't round to the nearest tenth because your eye can't measure a tenth of a drop. There's no instrument that measures a tenth of a drop. So there's really no good way. If you're calculating IV drops per minute, you never want to have 41.3 drops per minute. It just doesn't make sense because you can't count it. It's not a normal thing. But any other medication, if it comes up in mLs or if it comes up in milligrams, unless you're directed otherwise, you're going to round to the nearest tenth. And let me kind of put that up here. In big bold capitals, you're going to round to the nearest tenth. And then I'll change colors just so you see it a little bit bigger. And then I'll put this little directive until told otherwise. Okay, if for some reason you get a teacher who tells you to round to the nearest hundredth, or if you get, you know, some wacky pump that can do that, some micro whatever, something more sophisticated than what you're going to see here at St. Francis School of Nursing, you round to the nearest tenth. Okay, can I make that a little bit more obvious? Round to the nearest tenth. And if I see people not do it, I'm going to mark things wrong with a big angry red X. Okay, now the last thing I'm going to touch on is how to round. I know it's review, and if at this point you feel pretty confident that you know your basic math and you don't need this tutorial, then by all means shut it off, move on, that's fine. But I want to kind of show you something. So okay, people, we tell them round to the nearest tenth, and sometimes they don't seem to follow that direction. So I'm going to be very explicit. So let's say that you have a number and it's 3.54, okay? The tenth is the 5, okay? Now that sounds confusing, but all that means is that, let me here, get a pen or whatever. It's the first number, to the right of the decimal point is the tenth. The 4 in this number, 3.54, is in the hundredths place. If I had 3.547, the 7 would be in the thousandths place. So know what I mean when I say round to the nearest tenth. It means I want a number point, a number, okay? So if the number was, let's pick a different one, 13.9 or 87, okay? What I want there is 13.9, okay? That's rounding to the nearest tenth. Now, if you're not sure how that should look, okay, when you have a number that is let's say 12, 3.13, 3.14, you're going to have a result of 3.1. If you have a number that is 3.15, 3.16, 3.17, you kind of get the point. You're going to go up to 3.2, and what makes the difference is the number in the hundreds place. If it's 5 or above, you round up. If it's 4 or below, you round down. If you have trouble with this concept, please see me. I have some basic mathematics textbooks that I can lend you and sort of illustrate that concept and give you some practice. I'm not really sure why people aren't rounding to the nearest tenth when it's in 3 spots in the instructions, but it is making Professor Hernandez a little bit crazy, and so I am instructing you. All right.